All right, last day of Exponent-O-Rama. Feels like that, hasn't it? It's been kind of a marathon session of exponents. So we've talked about exponent rules. We talked about getting those exponent rules in when there are fractions involved. It doesn't change the rules. It's just an added little twist that we've got our calculator buddy or our rules of fractions in our head to help with. And now we've got our last piece of the puzzle, which is exponents to radicals. There are advantages of having rational functions in an exponent versus a radical form in different ways, whether it's equations, graphing, things like that. So we want to be able to go back and forth. It's like having another language that you can learn. The communication gets much better. Excuse me for a sec here. Oh, thank you. So, a little bit of vocabulary. We're used to exponents being fractional powers, you know, sort of this. When we deal with a root, okay, they're not always just square roots. They can be cubed roots, fourth, fifth roots. And so when we're talking about this, our index, okay, is going to be the little number out here. If there's no little number out here, we assume it's 2, because that would be for a square root. We've got our radical sign, and then what's called the radicand inside, which sometimes people can also refer to as a base value because it's the same base value. Okay, this is like our base with our exponents. And you're going to hear me refer to it that way when we're doing some of these. So when we're talking back and forth between exponents and radicals, same pieces, just in a different order. So for instance here, I may have a to the 1 over some power, okay? That denominator value in your power is going to be, in your exponent is going to be your root, okay? Going to be your index. The base is still the base. This is going to go here. So this is a better example to kind of let us see how you rewrite from one to the other. This is going to be your exponent, whatever exponent there is on your radicand, on your base, if you want to use that. I know we want to use the right language, but I also want you to be able to make connections here. So the exponent on your base, and then your index. So you're like, okay, maybe, Hardy. My ears are starting to smoke a little bit though, so I'm a little unsure. So as we start to practice these, I think it's going to make a little more sense. So write each of the following with fractional exponents. Okay. If you don't see the little number in here, for the start at least, I would suggest writing it in. That's a 2. And when we go to write this, okay, it's always going to be exponent over root. Exponent over root, or index at times, okay? And then if we can simplify it, we do. So we're basically taking the radical and we're turning it into a fractional exponent. But as long as I keep straight, exponent over root. One of the ways I like to think about it is exponent comes before root in the alphabet, okay? Even if we used index, exponent would come before it. So that always is what I'm going to write in first. Base, exponent, root. And then simplify the fraction if you can. Okay. And it's also true with variable terms. So here, remembering that there's a 1 there still. Okay, e is my base, 2 is my exponent, 3 is my root. And I move to my next variable term. F is my base, or my radicand. 1 is my exponent. 3 is my root. I can't combine them. They're different bases. But that would be what that would look like, okay, as a fractional exponent. So let's say you get, and we try to go the opposite. Write each of the following as radicals. Okay, now we're going to work this backwards. She's like, oh boy. So when I'm looking at this, I'm trying to make the comparison, and I'm like, okay, So when I'm doing it, let's see. So this is going to be my exponent. This is going to be, let me do this. My base is always going to be in there the same, my radicand. How do I tell which way this is going to go? This is still my exponent. This is still my root. Okay? This is still my exponent. This is still my root. That doesn't change. That doesn't change. The difference now is, though, instead of writing my answer with it, I'm using this to form my answer. Exponent, root. Exponent, root. Okay? There's a natural connection between them. I just got to keep looking at them and working through it that way. And it doesn't hurt to keep labeling them. Exponent, root. Now, could I simplify that more if I wanted to? Could I put that as the fifth root of 25? So maybe if I'm doing a multiple choice quiz sometime and I don't see this as an answer, if I simplify it, can I do that? And if I have this out, maybe I think of that. Okay? There's benefit here, people. I'm going to get you talked into this, yeah. I am. Last one. Exponent, root, exponent, root. And just keep playing with those. Okay? Now, evaluate with rational expressions. Okay? Let's try without a calculator. Now, I know it mentions on here using a chart. I'm going to post on my website, I am going to make a note to myself here that there are ways of doing this. Now, again, you're like, but wait, why would I do something else when I can just do 9 to the 3 halves and it spits out an answer and I just go, woo, 27. And why would I want to do something else? Again, when you get into like equation solving and stuff, having the ability to look at a value like this and use your steps to get to the answer does have value. Okay? So here's what I would rather have you kind of think through with this. Maybe we rewrite this as a radical. Okay? Exponent root. Now let's think about this for a minute, because I can look at this one of two ways. Okay? This is the same thing. I'm still taking this root to this power, no matter which way I write it. So if I look at this, I'm like, hey, what's the square root of 9? We know what that is. Square root of 9 is 3. What's 3 to the third power? 27. Okay? If I break it more into bite-sized pieces, I can tackle it and take it on. Now, sometimes maybe not. Like, for instance, maybe you look at this next one, and you're like, ooh. So, Hardy, this one would be 32. Hardy, wait, I don't even know where to start with this, because now I got a negative exponent. Can I have like a negative root out here? No. So here's what we're going to do. Let's do this. First thing we're going to do, we're going to flip it. Okay? We're going to send that to the denominator, just so it reminds me, hey, my answer is going to be a fraction. Okay? Once I get here, now I can look at it and go, okay, exponent root. Now, maybe you don't know at this point what the fifth root of 32 is. You're like, no. Okay, that's why I'm going to post the chart with some of the different perfect roots and perfect squares of things to try and help out a little bit and let you see that. But here's how we can do that. A couple different ways. This would be 32 to the 32, there we go, to the 1/5 power, which is 2, squared, which is 1/4. Now again, some of you currently may not see the value of doing what I just did versus doing Besides the fact I don't want to see a decimal, math, enter. Okay, I still get 1/4. But I'm telling you, getting that math logic, that math sense to be able to snap numbers off faster, as you move on in math, it's more valuable than trying to sit and go, hang on a minute while I punch this all in my calculator. Just saying. Here, we definitely don't need a calculator here. Holy moly. 4 to the 1/2. You're like, wait a minute. 4 to the 1/2. 4 exponent. Oh, it's just 1/2 is like the square root. Yeah. What's the square root of 4? 2. I mean, again, can I punch it in my calculator? Yeah. And I would check my answer that way, but I'd try it without. Just saying. All right, one more to take a look at here. So there's my base. There's my exponent. There's my root. Do you know what the square root of 16 is? What can I multiply by itself to get 16? 4. Now, no, I do not expect you to know off the top of your head what 4 to the 4th power is. If you do, call me impressed. You're like, but I still can go to the calculator if I want to? Well, let's see. Yep, still can. So you have options. So what we try to keep stressing here is a lot of times we're going to have options with things. Okay. It doesn't have to be a graphing calculator, but use a calculator to approximate. Sometimes you'll be asked for decimal answers, but if you're not asked, don't provide them that way. So how do I type this in? The same way I've been doing the rest. There's my exponent. There's my root. Exponent over root. Type it in. Okay. The nearest hundredth, 2 decimal places. 3.34. And we're good. And at any time with these, it's always a good idea, especially when we do 3 or 4 problems in a section, after we do a couple, freeze me, try it out, and then you've got a way of double checking to see. So here, there's my base, there's my exponent, there's my root, 4.3, don't go 4.32 on me. Okay, anything 5 or above rounds this number up, so 4.33. And again, if you haven't already, I would suggest you freeze me at this point. So you can try this one out on your own. Maybe you've unfrozen me at this point. Again, 4 is not larger than 5, so we leave it at 2.92. Okay, last piece. Write in simplest form. Holy cow, Hardy, what the? Okay, now remember, we got tools to deal with this. Okay, that 32 has a 1 on it, so we've got 32 to the 1/5. Okay, a to the exponent divided by root, b to the exponent divided by root. Now again, once I get that chart up, you can kind of take a peek at it, because this would be in that list. Get 2. 5 divided by 5 is 1. 10 divided by 5 is 2. Okay, reduce. We're good to go. And just keep it going. Here with these, just because it's a fraction, don't freak out. X to the exponent over root divided by y to the exponent divided by root. And simplify. 6 divided by 3 is 2. 9 divided by 3 is 3. Happy, happy, happy. We're off and running. Last one, again, if you haven't, give me a freeze. I would suggest writing these out, especially here, even if you think you've got this locked in where you can do the whole thing in your head. 16 to the 1/4 is going to come out nice. And the rest of these hopefully will as well. 4 divided by 4 is 1. 12 divided by 4 is 3. 20 divided by 4 is 5. Okay, so again, give these a shot. See how it's going. So we flip over here. Okay, here's our practice. So make sure, again, that you've given at least some in each section a try, because these need to be uploaded to your slide for the week. As always, through this week, I appreciate your stick-to-itness on this. Hopefully you're seeing this before Sunday afternoon, so you can ask some questions, but keep at it, keep pacing, and you're going to do a super job.